Been a very good evening, ladies and gentlemen. I hope this finds you in good health. So, welcome to yet another engrossing episode of Perceptive Learning Zone, and I'm your host, Mohammed Hamdan. And today, we are going to be talking about the scope of material engineering in Pakistan as well as abroad. Now, if we start from the most elementary level, that is bachelor's. So, a bachelor's degree in materials engineering and manufacturing, well, it is a program that combines principles of material science and engineering with the practical aspects of manufacturing processes. And this multidisciplinary field, it focuses on understanding the properties and behavior as well as the applications of materials and the techniques and technologies which are involved in their practices, right? You will explore various materials like basically the core materials, which are metals, ceramics. We're talking about polymers, composites, as well as semiconductors. And materials engineers, they study the properties, performance, and applications of these materials to innovate in fields like construction. You got automotive industries, you got biomedical industries, which apply these concepts. And furthermore, you will gain a deeper understanding of the atomic and molecular structures of these sort of materials. So, understanding these physical and mechanical properties and how they can be modified as well as optimized for specific applications is sort of like part and parcel of your course. So, this degree program's manufacturing aspect, well, it covers various topics which are related to industrial processes and production methods. So you will learn about different manufacturing techniques. This includes casting, you got forming. On top of that, you got machining, building, additive manufacturing, that is 3D printing, as well as surface engineering. And this program also emphasizes materials engineering, also stresses on the efficient use of resources, quality control, as well as sustainability in manufacturing operations. A question at this stage can be, what are my majors as a materials engineering student? So in this field, there are several applications, ladies and gentlemen, that you can consider for a degree. A few common ones that come in my mind, there would be composite materials, there would be nanomaterials, then there is metals and alloys, you got polymer engineering, you got ceramics materials, and obviously you got materials characterization and testing. And then if you talk about the duration of the BS Materials Engineering program, well, that is typically 4 years in Pakistan. And these institutions which I'll come to in a bit, right, which offer the degree of BS Material Engineering in Pakistan, they're all affiliated with the Higher Education Commission. Then a common question emerges at this point. Okay, well, I put in the hard yards and I complete a 4-year degree program. What are my career opportunities? So upon completing your degree, you will have the knowledge and skills to work in various industries such as automotive, aerospace. You'd go for electronics. The energy sector would be quite conducive to you. You could find job in the consumer goods sector, and obviously it's booming in biomedical sectors especially. So there are opportunities additionally in research and development. I'm talking about production engineering, quality control, material selection, process optimization, as well as last but not the least, project management roles. So yeah, this degree is going to open up a range of career paths where you can contribute to developing and improving materials and manufacturing processes. And this will ultimately shape your future of technology and innovation. Then after that, next time we talk about the syllabus of materials engineering degree program. So, well, this syllabus is a range of subjects related to material science, engineering principles, as well as manufacturing processes, right? So, I mean, obviously from institute to institute, the specific programs, scholars are going to vary, so it's best to consult the course websites of those particular institutes that are offering this degree. But some common programs that pretty much come almost everywhere are introduction to materials science and engineering, you got engineering mechanics, you got materials characterization, You got materials processing, you got mechanical behavior of materials. There is a course by the name of manufacturing processes. There is material science and design, thermodynamics and kinetics of material आज जाते हैं आपकी syllabus में. You got material testing and analysis, polymer science and engineering, ceramics and glass engineering, metals and alloys, composite materials. You got materials for energy applications. You got surface engineering and coatings. You got nanomaterials and nanotechnology, and yeah, you got quality control and inspection techniques as well. There's engineering economics and cost analysis pretty much comes everywhere. You know, as engineers, we're also, I mean, we are as much economists as we are engineers, right? There's industrial automation and robotics, and obviously there's project management and industrial organization as well. These are some common courses that come in my mind when the word material engineering pops in my brain, but obviously the best practice is to consult your respective university's course website for a more full-fledged understanding of these details. So I get this question in Pakistan a lot: why choose this program? So you see, this program, it is true, the scope is limited, but still there are several benefits and opportunities. You see, fellas, material engineering and manufacturing, they are multidisciplinary fields which open doors to various industries. So, like I said before, you got aerospace, automotive, electronics, energy, healthcare, and consumer goods, which are quite open for this. And I feel like ultimately it's about what sort of cause are you contributing to, right? And it is a technological era. There's no doubt that material engineering and manufacturing, they are actually at the forefront of technological advancements, right? Starting in this field is actually going to give you a wonderful pivotal opportunity to work with cutting edge materials and processes and technologies. It can offer the opportunity to contribute to developing new materials with improved properties such as strength, durability, and last but not least, sustainability. So a question emerges at this point. Well, okay, I do a bachelor's BS material engineering degree program. What next? What are my further studies options? Higher studies में मेरी क्या क्या और बाकी है? So for starters, you can do a master's degree in material engineering, right? I mean, that's a no-brainer. I mean, that's going to allow you to specialize further. Yeah, you could focus on specific areas like nanomaterials, biomaterials, composite materials, or advanced manufacturing techniques. Then, alternatively, you could also do an MBA, a master's degree in business administration, because an MBA, ladies and gentlemen, with a finance concentration, that is a popular choice for individuals who are looking to develop their careers in the banking and finance sectors. This degree is going to provide you a broader understanding of business functions and strategic management while offering specialized finance courses. So yeah, if you're looking for senior leadership positions in finance, MBA is definitely going to be your beef to chew. Along with that, you can do a master's degree in manufacturing engineering. This will give you more advanced knowledge and skills in areas like automation. You got process optimization, you got supply chain management, and obviously there is lean manufacturing, which material students would be quite well aware of. Then there is always this possibility of a master's degree in material science, right? So it's a very multidisciplinary field that combines principles from physics, chemistry, engineering, and this will give you sort of a more out-of-the-box exposition and understanding of materials, their properties, and their applications in various industries. And then, obviously, there's always the possibility of a PhD degree, of doing a PhD in material engineering or manufacturing. This will typically involve conducting original research, writing a dissertation, and potentially, most probably, pursuing an academic or a research career, right? Then, and this question is the next question is very something that I get a lot because of the limited scope of materials in Pakistan, right? People say, Hamza, what are my study abroad options, So if you talk about the US, the US actually has many, prestigious universities which offer very good material engineering programs. I'm talking about MIT, Massachusetts Institute of Technology. You got the Stanford University, you got University of California, Berkeley, and Georgia Institute of Technology. These are some institutions that pop in my mind, which are well renowned for their engineering departments. Similarly, if you talk about the UK, you got institutions like the Imperial College London, University of Cambridge, University of Oxford, as well as the University of Manchester, which are pretty well renowned for their material engineering program. Similarly, Germany gives you some enticing options like the Technical University of Munich. You got the the RWTH, Aachen University. You got the Karlsruhe University of Technology, which offered pretty comprehensive material engineering and manufacturing programs. So the job aspects of the job prospects for materials engineers in Pakistan, they are pretty much, like I said before, metallurgy, there is automotive, there is aerospace, there is electronics, there is manufacturing. And now we talk about the emerging renewable energy and nanotechnology sectors. They have sort of offered new avenues for material engineers to contribute in this country. You would be wondering, like, what are the major universities that are offering materials engineering in Pakistan? Well, some that come in my mind are the National University of Science and Technology in Islamabad. You got the Punjab University in Lahore. Then there's Ghulam Azad Institute. There is NED University of Engineering and Technology that is in Karachi, and Mehran University of Engineering and Technology in Jamshedpur. It also offered this course the last time I checked. So the main another question would be, what are the main research areas in materials engineering in Pakistan? Guys, the common research areas, they include nanotechnology, advanced composites, corrosion prevention, you got material sustainability, as well as renewable energy materials. There's also paramount emphasis on developing materials for defense applications and construction projects within the country. At this stage, you would be wondering, like, I'm sort of like praising materials, but we have so few students who actually opt for this because of the problem. So, what are the problems? What are the challenges that materials engineers face in Pakistan? And this is a very important topic that has to be addressed, because unless we don't find the solution to this dilemma, it would be really difficult to make materials engineering a much more promising and enticing career option for the upcoming generation. So I would say one problem for materials engineers right now is the limited access to advanced research facilities and resources. There are many universities and research institutions in Pakistan which lack cutting-edge equipment that is necessary for studying and developing new materials. For example, research in nanotechnology or advanced composites, which require sophisticated instruments like electron microscope or the AFM, the atomic force microscope. It is often constrained by outdated or unavailable equipment. The limitation sort of stifles innovation. It prevents engineers from conducting experiments that would lead to breakthroughs in material science. So ये एक बहुत बड़ा मसला है हमारे पास कि हमारी जो research facilities की तरफ access है वो बहुत ज़्यादा हमारा limited है. उसके साथ साथ एक और बहुत बड़ा मसला जो आता है, that is that there is a severe lack of funding for research and development. Pakistan's government and private sector, they allocate minimal resources to R&D and engineering. This leads to insufficient support for long-term research projects. Materials engineers, especially those working in academia, they often find it very challenging to secure grants or industry partnerships to sustain their research. So, for instance, projects that are aimed at developing sustainable materials for construction or renewable energy application, they may struggle to move sort of beyond the conceptual phase of the financial constraints. Another barrier that I feel is that the industrial infrastructure in Pakistan is not fully equipped to adopt advanced materials technology. While there is, no doubt, there is a growing need for innovative materials in sectors such as construction, automotive, and defense, industries are often reluctant to invest in newer technologies due to the costs involved and the absence of skilled labor that is sort of capable of handling these materials. For example, despite the potential of lightweight composites to revolutionize the automotive and aerospace sectors, manufacturers often continue using traditional materials like steel and aluminum. Why? Because of their like because they got their agendas, but generally speaking, they do that because of the higher initial costs and the lack of trained personnel to work with composites. We cannot forget the brain drain. I've obviously talked about this in detail. I don't really want to sort of go about the bush, but talented material engineers, they often leave Pakistan to pursue better opportunities abroad, where they have access to better facilities, they got more comparative, lucrative salaries, and a lot more career growth prospects. Obviously, this exodus sort of results in a shortage of skilled engineers in Pakistan. This limits the country's ability to sort of advance or propagate the material science sector. For example, engineers who specialize in high performance materials for electronics or renewable energy systems, they may opt to work in countries with more robust industries in those fields. This leaves Pakistan's industry struggling to fill critical roles. Also, I feel like there are environmental challenges and sustainability issues, right? Pakistan is facing significant environmental degradation, and there is growing pressure to develop materials that are sustainable, recyclable, and environmentally friendly. However, the industry's reluctance to adopt rare technologies and lack of regulatory frameworks, a lack of regulatory frameworks to support sustainability, this makes it very difficult for engineers to push forward such initiatives. For example, while biodegradable polymers or eco-friendly construction materials are gaining global traction, they are still in their infancy. They're still at a very nascent or preliminary stage of conception in Pakistan due to resistance from industries which focus or which prioritize short-term profits over long-term sustainability agendas. And finally, but last but not least, I feel like the nail in the coffin is corrosion and material degradation. These are widespread problems in industrial areas if you have taken a tour in recent times, particularly in sectors like oil and gas, construction, and manufacturing. Materials engineers are tasked with developing corrosion resistant materials, but they face difficulties in translating research into practical solutions. So the humid climate, the pollution, and suboptimal maintenance procedures, they sort of increase the corrosion issues, which leads to frequent material failures, and this ultimately increases costs for the industry. So engineers often struggle, I would say, bottom line, to implement corrosion prevention strategies due to limited resources and the lack of industry-wide standards for material selection and maintenance. These challenges, they collectively, aggregately, they hinder the progress of material engineers in Pakistan. They limit their ability to effectively contribute to Pakistan's industrial resurgence. And I feel it's very important going forward that we address these issues. Who has to address it? I mean, the government has to come inside the equation. The industries need to leap into the equation. Educational institutions need to put up their part to promote research infrastructure and obviously cultivate talents within the country. Materials engineering, trust me, it plays a vital role during Pakistan's industrial growth. It develops durable materials, it enhances your energy efficiency, plus it plays a very vital role in sectors such as steel, cement, automotive, and textiles, which help improve product quality and performance. Another question or query that I get is also that what is the significance of material engineering in the energy sector in Pakistan? And the material engineering is crucial for developing, I would say, new materials for energy production, storage, as well as transmission. This includes, guys, advancements in solar panels, battery technology, as well as materials that are sort of capable of withstanding extreme conditions, which are vital for Pakistan's growing energy needs and renewable energy goals, sustainable development goals. How do you integrate sustainability into material engineering? So sustainability in materials engineering, it involves developing eco-friendly materials, improving your recycling processes, and reducing materials waste. Wastage is a big problem, be it domestic sector or agriculture or industry, pretty much everywhere this menace is there. So researchers are also focused on creating materials that are sustainable, biodegradable, or recyclable, which can help reduce Pakistan's environmental footprint. And finally, you would wonder that what role does material engineering play in the defense sector of Pakistan? So material engineers in Pakistan's defense sector, they focus on developing stronger, lighter, and more resilient materials for military equipment, such as aircraft, armor, and vehicles. They are working, ladies and gentlemen, on advancing materials that are offering better performance in harsh environments while being cost effective for mass production. So these are pretty much the main queries that people have, which I sort of addressed in this session from a material engineering perspective. And obviously, me as an optimist, I'm just going to give you a couple of success stories for those people who are sort of motivated to go for this program. So one notable success story I feel of material engineering in Pakistan is that of Dr. Asghar Qadir. Dr. Asghar Qadir is a material engineer and researcher who made significant strides in advancing material science in the country. He specialized in the development of advanced composite materials, which are lighter, stronger, and more durable than traditional materials that were used in Pakistan's industries. He has worked extensively on creating corrosion-resistant materials for the oil and gas sector, a crucial industry for Pakistan that faces significant material degradation due to harsh environmental conditions. His work has actually led to the development of new polymer composites that could withstand extreme temperatures and corrosive environments. He has reduced material failures and played a big role in terms of lowering costs for companies. And despite the limited research facilities and funding, he was able to collaborate with local industries to implement these materials, significantly enhancing the efficiency as well as the longevity of the equipment. I mean, that's amazing. With all these constraints, hats off to the man. So his success sort of demonstrates that with determination and innovative thinking, guys, you can actually overcome resource limitations and contribute to the country's industrial growth. Always remember in life, obstacles don't block your path. Obstacles are the path. Tough times, they sort of test you, and it's how you deal in those times that sort of defines you as a person. So if you want to discover the purpose, the greater meaning of life, in the broader scheme of things, you either create a work or perform a certain deed, or you meet a certain individual or experience a certain thing, or you sort of test yourself, see how do you react in difficult conditions. That way, I feel you can find your legitimate purpose, be it being a material engineer or anything else in life, And finally, I think an international success story that I'd like to talk about is obviously Dr. Elon Musk, who is better known for his ventures in technology and space. But you would be surprised to know that material engineering has played a very critical role in success as well, particularly with SpaceX. So material engineers at SpaceX under Elon Musk's leadership, they developed the Super Draco engine, which incorporated advanced 3D printed metal alloys. And these alloys, they were designed for extreme conditions. They enabled the engines to function reliably during the spacecraft launch and re-entry into the Earth's orbit, which is an unprecedented achievement in the aerospace materials engineering. The Super Draco's success lies in high strength to weight ratio and resilience in high temperatures, qualities which are made possible by innovative, pristine material design. This development was sort of really critical, I would say, for SpaceX's breakthrough with a reusable rocket called Falcon 9, which dramatically reduced the cost of space travel. So Musk's ability to assemble a talented team of materials engineers and push the boundaries of what is possible in the field, it served as an inspiring example of how engineering can drive revolutionary change on a global scale. So I'm going to end this discussion by that saying that great engineering is not just about solving problems today. It is about imagining solutions for tomorrow and having the courage to build them, And a few lessons that we learned very late in life is one that you should always embrace uncertainty. A lot of people say, we want to do this, Hamza, but we are so confused. I'm like, that's okay. You got to embrace uncertainty. There is so much you can't control, be it in research, be it in your studies, be it at your workplace, or be it any other aspect or dimension of life. Along with that, remember that resilience is greater than perfection, ladies and gentlemen. It is literally greater than perfection. So perseverance is very important. You got to go on and on and on, because after all, the pain that you feel today will be the strength that you will assimilate tomorrow. And lastly, I would say learn to have good support systems in life. Just because you haven't figured it out today doesn't mean you don't figure it out tomorrow. I wish you guys Godspeed, and may the good Lord guide you in your quest toward achieving your ultimate career symphony. And please feel free to like, share, and subscribe. I would love your feedback, and we'll be back with much more illuminating content and engrossing episodes on behalf of Perceptive Learning Zone. So take care, guys, and see you soon. Stay blessed. Assalamu alaikum.